Group up here, the one that's done. We are recording, so make sure you be quiet. Let me say that again. Make sure you be quiet. Okay. I didn't know if you were disrespecting me or just wasn't listening. All right. So let's take this group right here. What did you pick for your card? Huh?
Hearts.
Just hearts? So you just picked hearts. Okay. So that would be the probability oh me. We're going to go through this ritual, I guess. The probability of hearts. Now, if you were just talking about the Mayberry probability, what would that probability be? 13 over what? 52. And somebody do that on your calculator. What's 13 over 52? 1/4.25. Okay, now let's see what you actually did. Name the cards that you picked in your 10 trials.
Like the numbers and the suit?
Yeah.
We don't have them written down.
Y'all might have been talking when I told y'all what to do. Follow directions. I said at the beginning, everybody listen to the directions. One person what? Writes them down. See, that's what I was talking about. You can't handle it. Usually it's the guys that do this. So let's go to somebody that wrote it down.
We have probability states.
Okay, what?
You
have it written down. All right, so let's do the cards. What did you call for on the cards?
We got the 8 of diamonds.
The what?
Probability states.
The 8 of diamonds?
Yes, that's what we started with.
8 of diamonds. So we'll say the 8 of diamonds. So tell me how many 8 of diamonds there are. There's only one, right?
Yes.
So that'd be 1 over 52. Somebody give me that. Point what? 0.019. Okay? So give me the numbers and the cards that you picked.
King of clubs.
King of clubs. I'm just going to put clubs. What else?
3 of hearts.
3 of hearts.
4 of clubs.
4 of clubs.
4 spades.
4 spades.
Jack of diamonds.
Jack of what?
Diamonds.
Jack of diamonds.
8 of diamonds.
8 of diamonds.
Jack of diamonds again.
Jack of diamonds.
Ace of diamonds.
Ace of diamonds.
And 2 of clubs.
2 of clubs. So did you actually get an 8 of diamonds? Very unusual. Okay, usually that does not happen. But in this case, did you do 10 times? I assume you did.
I didn't read all. I'm sorry.
So you didn't write down all 10 times?
We did, I just forgot to read one.
Okay, what are they?
The 9 of spades.
9 of spades? And what else?
That's 10.
Is that 10? 1, 2, 3, 4, 5, 6. Okay, I thought that was 5. All right, so you got 1 out of 10, which is the actual probability of 8 of diamonds. I can't draw a diamond, so anyway. Which is 1/10, which is 0.1. Again, do these match? No. Now, I was very surprised that you got an 8 of diamonds. Now, let's say that you bet a $500 bet on this. Would you make a lot of money? Yes, you would. Because let's do the probability of success. Probability of success of failure would be 51 over 52 divided by 1 over 52 multiplied by 52 over 1. So 52 to 1 odds, which would be 52 times 500, which is what?
$26,000.
$26,000. Again, I'm very surprised, even with 10 times, that you got 8 of diamonds, because usually that don't happen. Usually you go through and pick 10 cards, you don't even hit with that probability of 0.02. So it was, and you shuffled it each time.
Yes, sir.
Okay. How about the die? Let's go with the die. The die you roll, what did you pick on the die?
Probability roll 2.
Rolling a 2, which is 1/6. Probability of rolling a 2, which is 1/6, which is point what? 1/6 or 1/7? Somebody check that. Is it 0.17? Somebody check it.
Yeah.
Okay. So let's write down the numbers that you actually rolled.
6,
6,
3,
3,
5,
5,
2,
2,
4,
4,
5,
5,
5,
5,
6,
6,
5,
5,
and 1.
and 1. So we did actually get a 2 out of 10 rolls, so that's 0.1. 0.10. Again, they don't match. All right. Now, what about the probability? It's higher than 0.02, so your odds are not going to be as high. Let's do a 500 bet on this. So we got 1/6, so that's going to be 5/6. 1/6 multiplied by 6/1, and it's 5-to-1 odds, which means that you're going to win 25 what? $100 on a $500 bet. Why is it not 26,000?
Greater odds.
Well, there's more cards. Then there's less sides there's only 6 sides on a die. So the probability is higher because of what? There's only 6 sides. You're bound to hit one of those 6 sides. You see what I'm saying? Now, a lot of people say, well, the die is you can predict a die more than you can a deck of cards, and that's not true, because a die represents what we call a die. I can't speak this morning. Represents chaotic theory. What is chaotic theory? Well, let's say that you have a ramp right here. I did this last semester, but I'm not going to do it this semester. Take a ramp, and it's at the same grade, and you put the die at the same, you start on the same number each time. Like put the 6 up. And you do that each time. Will you roll the same number each time? No. And that's chaotic theory. Each time that die hits the desk off of that ramp, it's going to hit at a different angle. And it hits at a different angle, hits at a different corner, it's going to roll a different what? Way. So no matter how many times you put that 6 up, and you put it at the exact same point, draw a little circle, and you put that die at the exact same point, and you roll it down that, and you don't push it, you just let it go, and it rolls. It's going to give you a different number every time. Now, let's take an example, the number that y'all did. All right, what number shows up the most? Okay, so what would you naturally do if you were at this table in Vegas? What's the next number that you would bet on? All right, roll it 10 more times and tell me what you get. We're gonna pick a 5. We gotta let the gambling gods know what we're picking. Okay, we're picking 5. Everybody hear that? All right, now roll 10 times.
I got a 4.
Huh?
4 is the first number.
Oh, 4? Okay. 4,
3,
3,
3,
3,
4,
4,
4,
4,
6,
6,
4,
4,
3,
3,
6,
6.
and 6.
All right, well, we're going to do it this time. We're going to pick what? A 4. We're going to pick a 4. Guys, do you hear that? Probability of a 4. Go.
4,
Good.
4,
4,
1,
1,
1,
1,
6,
6,
4,
4.
4,
Okay, we got a problem.
1,
1,
1,
1.
3.
Okay, what do some of y'all suspect? Something's going on over there. Well, he could be rolling it kind of the same rhythm. He could be rolling it, but that is very unusual. What usually happens on the 3rd time I do this, another number pops up, like a 1 or a 2. 4 is not supposed to show up. That's the first time it's ever done that. Okay? The whole thing of this is the chaotic, the randomness. All right? When you throw a die, it's a whole lot more random than the deck of cards. Why is the deck of cards not as random? Because one, you're not throwing it. Throwing it, you've seen, Iron Man where he's and he throws it a different way, and then the guy Rhodey, he does that, and each time you throw it a different way. You can try to throw it the same way each time, but it's not going to happen. Okay? And you got how many corners on a cube? 6. Each one of those corners is going to throw it a different way. Okay? Not to mention where it hits on the table. So you've got too many variables of randomness on a die versus a card, deck of cards. Deck of cards, all of them are the same. You don't throw it, you pick. So there's a lot less randomness, but there's more cards. All right? So let's go with another group that wrote it down. Okay? Who's got everything written down? Okay? Give me what you picked.
Face card.
A face card. Probability of a face card is going to be equal to 12 out of what?
52.
52. And what is 12 out of 52?
0.23.
0.23. Thank you. All right. So let's write down what you got. Just give me whether it's a 2 or 5. We don't really care since we don't have to worry about the suits. What do we need?
We got a 6.
6.
A queen.
A queen.
A king.
A king.
Ace.
An ace.
4.
4.
2.
2.
6.
6.
4.
4.
4.
4.
3.
3. So we got 2 face cards, right? So that's 2 out of 10, which is 0.2. Very close. Very unusual. Okay? Because most of the time you don't get that close to a... Now, what explains this? If you notice, I'm trying to explain each thing. Why? Well, remember when we talked about the little old haired ladies club on Wild Hog Road? The logic part? There's only 2 places that little old lady could be going. Clemson, Pendleton, or Sandy Springs. And she's not going to Sandy Springs because she could have turned off 2 or 3 turns ago. All right, same concept here. There's got to be a reason, okay? So this is where we're explaining. We see a 0.2 versus a 0.23, which is very close. And you would say that's very odd, okay? But at the same time, the probability is a little bit higher than 0.02, which y'all pulled, what was it, 8 times? The probability is almost 0 versus 25%. You see what I'm saying? So, yes, you probably are going to hit more with the face card than you will with the 1 of diamonds. So let's bet on this one, okay? So if you bet 500 on this one, you're going to get, what's there, 40 over 52, over 12 over 52, 52 over 12, 40 to 12, and that comes out to be, what's 40 divided by 12? Somebody give me the 1 point what?
3.337.
All right, multiply that by 500.
1,660.
1,060,
Yes.
whatever. Why didn't we win as much? Because the probability is what? Higher. You get a probability, is everybody listening, or y'all just having your own conversations, or what? Okay. Interaction means interact with me, not each other while I'm talking. I know I'm bitchy this morning. This is rain. I don't know. Just disregard me, okay? Just don't talk while I'm talking, please. All right. The probability is 23%. All right. I'm sorry. 0.23. So naturally you would say, well, I'm not going to bet on this because I'm not going to get a lot of money. When the probability is between 0 and 10%, that's the biggest what? Payoff. All right. So you don't want to hang around 25% unless you're one of these people that just want to play it what? Safe. All right. Same thing with the stock market. You got 3 types of buying stock. You've got conservative, you've got semi-aggressive, and then you've got what? Aggressive. Aggressive means you want to make the most money you can the quickest. That's the greedy people. Okay? They want to make as much money as they can. And they'll go for the stock that what? Has the lowest what? Or the lowest probability. So therefore, if they put their money in that stock and it grows, then boom, they got a lot of money. All right? So that's the same way with stock market. Stock market, poker, same way. I mean, gambling, same thing. All right? Anyone else? Oh, what'd you do on your numbers? Let's write down your numbers.
We did the probability of 6 on that.
Probability of a 6 is 1/6. So that's going to be 1/6. Okay, what'd you get? Give me the numbers.
2,
2,
1,
1,
3,
3,
4,
4,
5,
5,
2,
2,
1,
1,
1,
1,
5,
5.
6.
So it's got 1 out of 10, which is 0.1. So again, that's 0.17 versus 0.10. Now, of course, if you did it 20 times, you might get closer to that probability. All right? Remember, the large number rule says that the more that you do, the closer that the physical probability gets to the Mayberry probability, or the classic probability, or what you actually observe, gets closer to the theoretical probability. Everybody agree with that? Everybody have a problem? Anybody got a question? Now, again, it's not a big deal, but it's something that you actually can see that, there's two different probabilities. Question. Okay. Now, the next thing we're going to talk about is going to be the additive rule and the multiplicative rule. The additive rule and the multiplicative rule. Okay? Now, if you look in your books, and you, those of you that have the cards or the die, just put them back in the box and put them on this desk when you leave. Okay? You don't have to do it right now. But usually there's a word that goes with each one of these. Okay? One word is and, the other one is or. Okay? With the additive law, you've got to remember one thing, and I write it in red. Always subtract the overlap. Now, you're not going to see that in any book. That's a Hubertism. That's something that I always tell students, because the way I show it, it's real easy if you do it the way I show it. Okay? And you always subtract the overlap. If there's no overlap, then you don't subtract it. It's raining. Dang old hurricane light. It's going to destroy the area. Everybody go get survival kits and milk and what? Bread. Yeah. Okay, yeah. Well, it don't matter.
We always have the best.
And run around in a panic and run around in circles. Okay? Now, for the multiplication, you have to worry about one thing, and that is with replacement or without replacement. Now, I call it with replacement or without replacement, but of course, the book has to, academia has to make it more complicated. So without replacement is independent. With replacement is dependent. So you need to make that, and I hope I didn't get it screwed up. Okay? Now, I think, somebody look in your book, but I think, I always get this screwed up. I think the additive law is the word or, and the multiplicative law is the word and. Somebody look that up for me if you don't remember it. But in 4.2 or 5.2, 5.3, you should be able to see the additive law and the multiplicative law. And somebody look in there and tell me if I'm not right. I believe, I always get mixed up. The word is or with and I'm sorry, with an and with multiplicative law. Somebody look that up. It'll be in the box, colored box that talks about the probability of multiplicative, and it'll say, look for the word and or look for the word or. And we're gonna talk about that as soon as y'all verify it, because I forget it. Usually the additive law is gonna be in some form of a table. If it's not in some form of a table, you need to put it in the form of a table. And I will give you a table right here. And we're going to call this RH negative and RH positive. And what is it? O, A. What's the different AB? What's the different blood types? There's 4, right? O, A, AB, and B. Y'all make sure I'm right, I think. I don't know. And I'm going to put 2, 4, 6, 8, 10, 12, 14, 16. Now, I do know that AB negative is the most, I know that, and I've got several degrees, I know that. This is just, I'm putting in numbers, okay? I don't need somebody saying, well, AB negative, it's supposed to be the smallest. Shut up. Okay? Now, if I ask for the probability, did somebody find out if or and is correct?
Or is for add and for multiply.
Thank you. So I didn't screw it up. Thank you. All right. So the question will say, blah, 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 blah. Find the probability of blah or blah. Okay? And that's going to be at the end of the sentence or the end of the question. And I'll just make up one right now. Probability of O or AB. So how do we do it? Well, the first thing you do is you find the total. Always find the total. With probability, when you find the total, you've done half of it, okay? So the total is 10 and 12 is 22, 36, what is that, 52, 60, 60, 72. Somebody check and see if it's 72. Is it? Okay. So 72 is your total. And then O is going to be 12. Man, I forgot something. Hold on. Take my highlighter. O, and take my green highlighter. And what did I say? AB? Okay, so there is those two, and I'm going to make my 2, that's 2 plus 10, okay? Plus, I do think, y'all should be so thankful I do all this for y'all. Do colors. Plus, what? 6 plus 14. Is there any overlap? No, there's no overlap. So I'm going to put out here minus 0 because I don't have an overlap. And then you just do 2 plus 10 is 12. 12 plus 20 is 32. 32 over 72 is your answer. Somebody check my math, make sure I'm right. So your answer is 32 over 72, and you would use right and decimal. I don't care about that, okay? That's your answer. I'm just showing you how to get the answer. You can reduce and change into a decimal according to the directions. But there is no overlap. Yes, sir.
This probably looks down dumb, but what is like overlap?
Overlap. That's what I'm fixing to show you.
Okay.
Okay, not being charged for a while.
I didn't.
That's all right. You're gonna fail. Just leave. Just leave. Just get out of my sight. All right. So we're gonna take. You're tough. You can handle it. We're going to take, I have to do this because if I try to erase everything, it just blows up and I just don't want to do it. All right, so now I'm going to do the probability of O or RH negative. No coughing in class. All right, now take the handy dandy O. And now take the handy dandy RH negative. Oh, I heard somebody's light go off. All right, so we got 72. And then we've got, I'm just gonna do the math in my head. Can y'all handle that?
Yeah.
All right, 2 plus, y'all can handle 2 plus 10, all right? That's 12. So I'm gonna put 12, I'm gonna put 12 in yellow. If I could work that's 12. And then plus, in the green, plus what? Well, let's add, let's say 6 plus 4 is 10. That'd be 20 plus 20. And then in red, I'm going to minus the overlap. Minus what? 2. The 2 is the overlap. Now that's why you must always try to put these in a table form. Sometimes they're going to give you the question in a sentence form, and you need to change it to a table form because it makes life a whole lot what? Easier. And that's how you do the additive law. So always put it in a table form and always subtract the overlap. Now, let's go ahead and write the answer down so you know you got it right. 12 plus 20 is 32. 32 minus 2 is 30. So your answer is 30 over 72. Reduce and write accordingly to directions. All right, now, we'll do one more for your notes so you'll have it. And I like to put this one on the test if I can find it. I just put the table. And the reason I like this one is because you have like 16 questions in one question. You can do like 5 or 6 of these. And I'm going to give you one more for your notes. And I'm going to give you probability of AB or RH positive. I'm going to let y'all do that one. And if you can't do it, just write it down as failure and a disappointment to your family. Where's Miss Kathy? Is she in the ditch drunk? What's wrong with Miss Kathy? Yeah, she's probably passed out. She needs to go to Alcoholics Anonymous. So, let's take our handy dandy highlighter, and yellow is going to be AB. And the other one is going to be RH positive. And now we're going to put it all over 72. And that's going to be yellow. And that's going to be 20. And the green is going to be, let's see, 16 and 14 is 30, 40, 52. And then what's the red? Minus what? 14. See how simple that is? I will tell you right now, I've seen some teachers, I've evaluated teachers in the last 5 or 6 years here at the Anderson campus, they lobotomize you teaching you this. And it's not that difficult. You just put it in a table form and you use your highlighters. And if you can't do that, you don't what? You don't tell anybody. Okay? Because that's simple. That's as simple as I can make it. So what's 20 plus 52? That means I got fired. 72 plus minus 14. Somebody give me that number. 58 over 72. Reduce and write as decimals accordingly. So that's all you got to know. As long as you put it in a table, you shouldn't screw it up. Shouldn't. Exactly. Some people break an anvil with a banana. If you don't know what an anvil is, don't tell anybody. Google it and look it up, okay? That's what you do with Google. That's what Google is supposed to. You know how many times I use Google? About 6 times a day. Because there's always a word that some of these flootsies put out that I don't know, so I have to look it up. Okay? You ever met somebody that uses big words? Well, I have to look half of them up, like yawning. Okay? All right, so what do you do with multiplication? Multiplication, just remember the dang old marble bag. Marble, not Marlboro, marble bag. Now, the marble bag is what, before we had Game Boys and phones and all that, people, played with whatever they could get, okay? Marbles, baseball, playing baseball, kickball, things like that. Okay? So, there's 3 red marbles, 4 blue marbles, and 6 green marbles. Now, I'm just making this real simple because I've got to explain to you the difference between with and without replacement. All right? With replacement, okay, means that you pick a marble out of the bag, you write it down, and then you what? Put it back. Independent means that it does not change future outcomes. With replacement is independent, meaning it does not change future outcomes. The next one you pull out is going to be, what's the total? 13? Everything you pull out of the bag is going to be put over 13 because you're putting it back in the bag after you write it down. Capiche? What if you was to take a blue marble or pick a marble and put it in your pocket and write it down? Then it's without replacement, and therefore instead of over 13, it changes to what? Over 12. Then you pick another one over 11. Pick another one over 10. That's the difference between with and without replacement. Make sure you know the difference. All right? Now, usually the probability is going to be written, the probability of picking a red marble twice. Red and red. Meaning you pick 2 marbles. What is the probability of picking red and red? Now that's going to be very what? Low or high?
Low.
Very low. The probability of you picking 2 reds simultaneously back to back is going to be very low. But you don't have very many marbles, so it might be semi-high because you only got 13 to choose from. Now, if you had 107, it'd be very low. But anyway, so we're going to take 3 over, what did we say it was, 13? And this is with replacement. Most of the time, it's going to be with replacement unless specified in the directions. Write that down. It's kind of like the square root. You don't have a square in front of the radical. It's assumed to be a square, or a 1 in front of an x. Well, when you're dealing with probability, my God. What the heck is going on? I bet you $1 saw these dadgum announcements, isn't it? No? It's not? Questions, homework questions. Let me turn that off. Okay, so you got 3 over 13. Now it's with replacement, so that means the next one is going to be what? 3 over 13. So, in other words, 3 over 13 raised to the what? Second power. 3 over 13 raised to the second power. Now, remember this. If it asks for 2 or 3 times, that's always going to be your exponent. So if I say pick 2 times, or pick 2 reds, it's going to be to the second power. If I say pick 5 reds, well, it can't be. Pick 5 greens, it's going to be to the 5th power. Why? Because you're not changing the denominator. Everybody with me? You're not changing the denominator because you're putting the marble back into the bag after you pick it. Okay? So whenever you're dealing with replacement, that means that the exponent is going to match the draw. So somebody take 3 over 13 and raise it to the second power, what do you get? 3 over 13, and then raise it to the second power. I thought y'all were on the calculator drill team in high school or something. Don't they have like drill teams for calculators? What is it?
0.05.
I'm sorry, what?
0.05.
Okay, 0.05 is close enough. All right, now what about with replacement or without replacement? I put it in my pocket. What is the probability of picking 2 reds? So then it would be 3 over 13 times what? Be 3 over 13 times 2 over 12. That's without replacement. Because once I pick the first one, it goes in my pocket. How many reds are left? 2. And then how many are left in the bag? 12. If I picked again, it would be 1 over what? 11. So if somebody take 3 over 13 and multiply by 2 over 12, what do you get? I'm sorry, what?
6 over 156.
Okay, give me the decimal, please. Just 2 decimal places.
0.104.
0.10.
Actually, wait, sorry, I'll 0.04.
Okay,
Okay,
just
we're-
tell me the wrong answer. That's fine. Let's just set me up for failure. 0.04. Is there a difference? Yes. When is there not a difference? When is there not a difference for some of you people that invented statistics? When is there not a difference?
When it's not repeated.
3 or more digits. 3 or more digits. When you're talking about 300 or more, does it matter which, is it with or without replacement? No. So let me show you an example of that and we'll finish today. I don't know what time it is. Somebody tell me what time it is. What? I still didn't hear you. I'll just look at my phone. Because everybody talking at one time, it sounded like blah, 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 blah. Okay, 9:09. Is that what y'all were saying?
Yeah.
Okay. Let's say you work in a CD plant, make CDs. Okay, and this is just a question that's on a standardized test. And you're the quality assurance person, and you go through and pick CDs out of a pallet of CDs, a big old case of CDs. There could be 10,000 or 1,000 or whatever, but let's say there's 5,427 CDs in this box. And you go by and you pick 5 CDs and you check them to see if they're all bad, then you send the box back into the company that made it or into the section that made it. If there's not any bad ones, then you send it to Walmart or Target or whatever and let them deal with the refunds, okay? But you pick, and by past quality assurance, you know that 10% is bad. You know from previous boxes that have went out, 10% are bad. Okay, so I want you to pick 5 CDs, and what is the probability of all them 5 CDs being bad? Now, you're in quality assurance. Are you going to pick a CD, check it, and then put it back in the box? No, quality assurance don't do that. Quality assurance is always without replacement. Always. But does it matter whether you do with or without replacement here? No, it doesn't, because you're talking about 4 digits. Okay, so it really doesn't matter. I'm going to show you. Let's change this to 3, because I don't want to do all that math. Let's change this to 3. Okay, so that means we got how many bad? Well, 543 are bad. And that means, give me the complement. What's 543 from 542.7? What's the complement?
4884.
488 what?
4.
4 are good, but you really don't care about that. Okay? Now you focus on the 543. So 543 over 5427 raised to the third power. Somebody do that for me and give me 4 digits. 0.0124. And then meanwhile, somebody over here do 543 over 5427 times 542 divided by 5427, 26, right? And then 541 divided by 5425. Somebody do that math for me and give me 4 digits. No sneezing, please. So somebody get, what's 543 over 5427 raised to the third power? Okay, I'll wait.
0.001.
Is it 0010?
Yes, sir.
Okay. Now somebody do that math and tell me what you get.
0.0009.
0.0009, which is what? 0010, 0.0009, which is no what? No different. So when you're dealing with more than 3 digits, then what? It doesn't really what? Doesn't really matter which method you use. So you need to look over that when you're talking about the multiplicative with or without replacement. If you're dealing with 3 or more digits, over 300 maybe, then it doesn't make a difference. Okay? All right, now you should be able to work on 4.1, 4.2, 5.1, 5.2, and 5.3, I think. Question? Any questions? Y'all all good? Nobody's got any questions? And I'm so good at this that y'all don't have any questions.